All right, today we're going to talk about different types of data, several words today, not many numbers, but hang in there, a lot of definitions. Make sure you get good notes and get the definitions down. First two we've seen before, parameter. Parameter is just a numerical measurement that describes a population. Remember, a parameter goes with a population. You remember about the two P's. A statistic is some kind of number measurement describing a characteristic of a sample. Remember, a sample is just part of a population, and you can remember so easily because they start with the same letter. Parameter goes with population, statistic goes with sample. So they're going to give you problems like this. Tomorrow in class, in a Harris poll, 2320 adults in the U.S. were surveyed about body piercings, and 5% said they had a body piercing. Seems like more than that, but not on the face. Thank goodness. Based on the latest available, at the time of this writing, there are this many people in the United States. That's a lot. The results from a survey are a sample drawn from a population of all adults. So the parameter, the only thing up there is a parameter that describes the whole population is the number of the population, 241, 472, 385 adults. That is the population or the parameter. There's two statistics up there. One is 2320 adults who were actually involved in the survey, and the other one is 5%. 5% of them, of the sample. It wasn't 5% of the entire population, it was 5% of just our sample, so it's a statistic instead of a parameter. Two main types of data. These are so important. Make sure you get these down really good. Quantitative data is basically consists of numbers, and you can count them and measure them. For example, ages of people who respond to a survey, heights of people, people's shoe size, and anything that can be measured with a number and you can count them or measure them with a number is quantitative. The other type is categorical. Categorical, mainly names and labels. There can be a number, but it's not a number like you're thinking it is. But you can't count or measure them. Like, what political party are you affiliated with? Are you Democrat or Republican? What's your eye color? Blue, green, brown, etc. Now, football jersey numbers. Those are numbers, but do they actually measure or count anything? And the answer is no. So they're still categorical, and that's a little bit confusing, but because you think, well, quantitative is any kind of number, but you have to be able to measure it or count it, and you really can't, you don't use football jersey numbers to count anything or measure anything. Two more big words. Keep on coming today. Discrete data. Both of these are quantitative. They're both numbers, but discrete is numbers that are finite or countable. Even if they're infinitely many, they're still countable. The best example here is how many tosses of a coin before you could get tails. And you can count that. Now, technically, you could toss a coin forever and never get tails, but you could keep counting how many times you're tossing the coin. Anytime you can count like that and hit every single number that's involved, that's discrete. Now, the other type is continuous. Continuous, it says data values that result from infinitely many possible values, where the collection of all the values is not countable. It's impossible to count the individual items because some of them are on a continuous scale. For example, if we're talking about data that will answer from 0 to 12, it might be, or centimeters. It could be 1 centimeter, 2 centimeters, but it could also be like 1.55 centimeters, 1.56 centimeters, 1.5556667777 centimeters. Infinite amount of values between 0 and 12 centimeters, as weird as that sounds. So that's called continuous because you can't count every single measurement because they're infinite. And discrete, you can actually count. They're countable. A couple of good examples here of that type. Discrete, the number of eggs that hens lay in 1 week are discrete because you can count that very easily. How many eggs did they lay? There is such thing as discrete of an infinite type, and this problem says consider the number of rolls of a die to get an outcome of 2. It may be 1, maybe 2, maybe 10. You could count you could keep rolling that die for the rest of your life and never get a 2, but you can keep counting them. Okay, number 3 is the difference. Continuous data. During a year, a cow might yield an amount of milk that's anywhere between 0 and 7,000 liters. Again, in between 0 and 7,000 is an unlimited amount of numbers. It's an infinite amount, so you really can't count every single value that you could get. So that's continuous. I wrote Diet Pepsi down at the bottom. That's my drink of choice. You probably see me drinking it sometime. And I thought of a good example with that. Discrete would be how many bottles of that I may drink per day. Continuous would be, okay, how many ounces did I get? Because technically there's not exactly how many ounces in the bottle it says there is, or maybe I didn't finish the whole bottle. And that measurement is, is so continuous because it could be anything between, 0 and 16 or whatever. 4 levels of measurement. This is the last thing we're doing. The first type is nominal. Nominal is like categorical. It consists of names and labels and categories. You can arrange it in order, such as low to high. And here's some examples. Yes, no, undecided if it's a survey. What political party in a survey? Social security numbers. You can't really order those. The second type is ordinal. Ordinal is when you can arrange it, but you can't really do anything with the differences. You can't do anything with subtraction with it, or the differences are meaningless, like your grades, A, B, C, D, or F. You can arrange them in order, but you can't say, well, A is twice as good as a B, or if you subtract A minus B, you get 8. You can't really subtract, you can't really find a difference, but there is an order. So that's one step up from the last for nominal. The next step up is called interval. This is when you can arrange the data in order, and you can find the differences between the data values, and they are meaningful. The differences are meaningful, but they do not have a natural zero starting point. Temperatures, for example. Outdoor temperatures of 40 and 90 are examples of an interval level, but because you can put them in order and you can find the difference is 50, but there's not really a natural starting point. Like, you don't start with 0 degrees and say, well, that's the coldest it can get. That's not really true, as you can get degrees that are below 0. So there's not a natural 0 with temperatures. That's the interval, which means the next level. All right, the ratio level is the last level. That's the best level, the highest level. You can do everything with them. It says you can arrange them. They can be arranged in order. You can find the differences. The differences are meaningful, and there's a natural 0 starting point. Got an example down here. The 0, by the way, indicates none of the quantity is present. That's what the 0 actually does. Like, the temperature wasn't one because 0 degrees doesn't mean there's not a temperature. It's just cold. Car lengths. Great example. Car lengths of 106 inches for a smart car, very small. 212 inches for a Mercury Grand Marquis. And of course, 0 means the car has no length, which I've never seen one of those. 212 is twice as long as 106. So there's a ratio. You can double a car in length, half of a car in length. You can do all of that. So you can really work with that kind of numbers, the ratio level. What I've done on the last slide, this is just a good little note-taking thing here. If you want them, maybe take a screenshot or something. This has every single level, all 4 levels of measurement, a little description of them, and then an example on the far right. So I just put that in case you wanted to see that. No big deal there. So we'll go over this stuff in class tomorrow as usual, and I'll see you then. Look forward to seeing you.